Hello my dears. So in the last class we discussed about the inductance calculation for both symmetrical as well as the unsymmetrical network, my dears. It's a very important concept for calculation of unsymmetrical, right? Unsymmetrical GMD is very important. So in the examination any type of question may be asked depending upon the level of the examination. So you just remember the equation 2 into 10 raised to minus 7 into ln d by r dash, that is the single phase concern, and for three phase unsymmetrical as well as symmetrical you can remember 2 into 10 raised to minus 7 ln GMD divided by GMR. Okay, so today we are going to discuss about the capacitance, single phase capacitance of single phase two wire system. Capacitance of single phase two wire system. Again consider two conductors, my dear. Plus I and minus I are the current which is flowing through the conductors, and you have to calculate the capacitance between these two lines. So the capacitance between, suppose let be A and let be B, so CAB, it is actually again a very long proof, so we don't want that proof, we just need the equation. Pi epsilon divided by ln d by r, that is the equation for, that is the farad per meter. Farad per meter. This is the per phase capacitance of the two lines which is flowing. That is nothing but, my dear, the two transmission line just above you are, and the capacitance between that two line is the equation CAB is equal to pi epsilon divided by ln t by r farad per meter, where epsilon is equal to, you know all this, epsilon is equal to epsilon naught epsilon r, and epsilon naught value is nothing but, my dear, epsilon naught, you know this, 8.854 into 10 raised to minus 12, right, farad per meter. Okay, and epsilon r is equal to 1 for air. Epsilon r is equal to 1 for air, and mu r equal to 1 for aluminium. Okay, epsilon r equal to 1 for air, and this is the general equation of a capacitance between two lines, my dear. This is the general equation of a capacitance between two lines, and you have to note one important fact here. See, in the denominator ln d by r only, I didn't take r dash. Why? I didn't take r dash because in the inductance calculation I took d by r dash, that is the effective resistance, I mean effective radius I put into consideration. But while here ln d by r only, I didn't take r dash. Why? Because in the capacitance calculation, my dear, capacitance is associated with the charges. In the conductor, at the periphery only charges will be distributed. But in the case of an inductance, the magnetic field will be inside of the conductor also, there will be some magnetic field. So there will not be simply R where the magnetism will exist, but 0.7788 R at which the magnetism will exist. What is the meaning of that GMR? What is the meaning, physical meaning of this GMR is, my dear? It is 0.7788 R means, suppose this is the conductor, my dear, this is the having resistance, I mean radius R, but up to 0.788 R, up to 0.7788 R from the surface, my dear, there will be conductance. Sorry, there will be the magnetic field. There will be the magnetic field. Okay, from the surface to 0.778 R, up to that there will be an influence of the magnetic field, and hence there will be the influence of inductance also. That is why we considered GMR as a 0.7788 into R. But in the case of capacitance calculation, I already told you, the charge will be distributed only on the surface. So we don't want to consider about 0.778 R up to. We don't want to consider that. We simply consider R only. That is why in the equation pi epsilon divided by ln d by r. You just remember this equation, my dear, not the derivation and all. You just remember this equation. And listen, my dear, suppose this is a capacitance. So this is the conductor having radius r. Suppose this is B, and this is another conductor again having radius r, and which is separated by a distance d. Okay, suppose this is B. This is one conductor, my dear, and beneath that there is earth. You know this? Beneath that there is earth. Earth is a earth is an accumulation of lot of plus minus charges. Earth is an accumulation of lot of plus minus charges. So there is also charges in the earth. In the conductor also there are charges. So two charged conductors, similar to that, two charged conductors again separated by, in between there is an air. So two conductors are again separated by air. That situation again arises. So due to that, there may be a capacitance called CAN. Here also there may be a capacitance called CBN. There CAN and CBN is called the neutral capacitance, my dear. CAN and CBN called the neutral capacitance. CAN equal to CBN called neutral capacitance. Or earth capacitance. Is it clear? Did you get what I am going to say? Did you get what I am going to say? There will be a capacitance offered by the earth also, my dear, due to the presence of charges in the earth. There may be capacitance in the in between this conductor as well as the earth. Let that capacitance be CAN as well as CBN. So see, this is one conductor. So I can represent it like, my dears, I can represent the same figure like, this is R, this is again R. Can I represent like this, my dear? CAN, CBN, and this is A and this is B. Can I represent like this? Because here is one capacitor to ground, here is one capacitor to ground. So I just modified the figure like this. Is it clear? Now by looking here, by simply looking in the diagram, what is the capacitance between CA and B? Let be CAB. What is that? CAB will be nothing but, my dear, CAN as well as CBN in series. Am I right? CAN as well as CBN in series. Correct now? So what is CAB now? CAN series with CBN, which is nothing but, my dear, two capacitance in series means the effective capacitance will be CAN into CBN whole divided by CAN plus CBN. CAN plus CBN. Here a very interesting fact you have to note that here CAN will be equal to CBN. CAN will be equal to CBN because this is just plus I, my dears, and this is just minus I. Both having same current but in opposite direction. So the capacitance will be, the magnitude of the capacitance will be same now. The magnitude of the capacitance will be same. So we can say that CAN will be exactly equal to CBN. CAN will be exactly equal to CBN. So substituting this equation, we have CAB will be equal to CAN into CBN is equal to CAN whole divided by 2CAN, which is nothing but, my dear, the CAN and cancel, CAN divided by 2. So I can say that CAN will be equal to 2 into CAB. Very, very, very important relation, which is equal to CBN. It's equal to CBN. So CAN equal to CBN equal to what? 2 times CAB. That means the earth to, that means the neutral capacitance or the conductor to earth capacitance is double as that of the capacitance between the conductor. That very important conclusion you will get from this equation. Very important conclusion you will get from this equation. CAN equal to CBN equal to 2CAB. What is that? 2CAB. Many examinations, this relation, it is directly asked. So that much important these relations. That much important the relation is. Please note it down. Please note it down, my dears. Please note it down. Is it clear? Is it clear, my dears? Is it clear? So the capacitance between a line and the neutral is actually calculated. A capacitance between line and neutral is nothing but, my dear, CAN is equal to, or CBN equal to, or simply C is equal to 2 pi epsilon divided by ln d by r. In general, for symmetric or unsymmetric spacing, CAN equal to CBN equal to 2 pi epsilon divided by ln GMD divided by GMR, where 2 pi epsilon divided by ln GMD divided by GMR is always R itself. So that is very, very important relation. Farad per meter. Okay. So in the capacitance calculation, if you are taking GMR, you don't want to multiply it with the 0.778 into R. No need of that. I already told you. What is the reason? If you are simply neglecting that, what is the reason? I already told you. So just keep in mind. Okay, just keep in mind. So that is all about the capacitance of either 3-phase. It is a single phase 2-wire system now. So per phase capacitance is always calculating. We are calculating the per phase capacitance, mind. This equation now, this is valid for per phase. This is for per phase. So this equation can be applicable to both the things, the single phase supply as well as 3-phase supply, because it is per phase. The capacitance is always calculated with one line with the ground. That is the capacitance. Is it clear, my dear? One line with the ground. But there is, in the case of an inductor, it is not like that. Inductance is always between two conductors or loop inductance. Is it clear? Per phase inductance or loop inductance. Correct na? Loop inductance. Is it clear? So, but in the case of capacitance, it is always with one line with the earth. That is the capacitance calculation. Because in inductance, there is no influence of earth. Only two conductors will be influenced each other. There is no influence of earth. So that in inductance calculation, there will not be any consideration regarding the earth. There is only two conductors or loop inductance we are calculating. But in the case of capacitance, there is no loop capacitance. And after all, there is no capacitance between the conductor. We need the capacitance to a line and the earth. That is the consideration. Is it clear? So capacitance is always calculated with respect to earth. Inductance is always calculated with respect to other conductor. That is the main thing you have to note here. That is the main thing you have to note here. Is it clear, my dears? Is it clear? Is it clear? Is there any doubt you can ask? Is there is any doubt you can ask? Okay. Okay. Pakka. Okay, my dears. Next one, type of transmission line. So just by heart this, my dear, that's all. Nothing is to explain. Short transmission line is less than 80 kilometer and up to 20 kV considered to be short transmission line, and medium is nothing but 80 to 240 kilometer and 20 kilovolt to 40 kilovolt, and long transmission line is considered to be a 240 greater than 240 kilometer transmission line is considered to be the long transmission line, and its voltage will be greater than 100 kilovolt. That's all. A chance of one word question from this, that's all. Chances of one word questions from this only. Okay, and next analysis of transmission line. Analysis of transmission line. In which first one? Short transmission line. Short transmission line. Normally the analysis is done with the help of an ABCD parameter, my dear, ABCD parameters. So many method you can use, but the most efficient method or simpler method or less calculation method is nothing but ABCD parameters, right? So by using ABCD parameter we are doing the analysis. What is the meaning of analysis, my dear? What is the meaning of analysis? Analysis is nothing but, my dear, you have a sending end. I will explain. So a short transmission line can be, I already told you, the transmission line consists of the equivalent, that means the parameter of the transmission line is nothing but, my dear, R, L, C and G. In short transmission line, these two will not be there. Just R and L will be there because it is less than 80 kilometer now. So we won't consider the capacitance as well as the conductance, but only we consider resistor as well as the inductance. So a short transmission line can be represented like just that of R and JXL, and there will be a sending end current as well as the sending end voltage, and there will be a receiving end current as well as the receiving end voltage. That's all. This is the representation of a short transmission line. This is the representation of a short transmission line. So the short transmission line parameters, the analysis of transmission line is nothing but, my dear, analysis means we have to make connections between VR, IR, VS, IS. That's all. That is the concept of the analysis. That is the concept of the analysis. Or in other words, the performance of the transmission line can be measured, determined by this analysis. Suppose you send a voltage of Vs is equal to 100 volt. You received a voltage of VR is equal to 80, but you can conclude that there will be a loss of 20 volt across this, and you are noting it. Okay, it is a short transmission line. Okay, just note the equivalent circuit, which is consisted of R and JXL. Oh my God! So between this R and JXL, there is 20 volt loss. 20 volt not loss, 20 volt drop. So you can adjust the value of R and L so that the drop can be minimized, and you will get nearly the sending end voltage at the receiving end, so that the transmission will be improved, or the receiving end voltage will be similar to or same or slightly less than that of the sending end voltage, means you succeed. The transmission or the distribution is good. The transmission, now we are dealing with the transmission, the transmission will be good. Or you send 100 volt there and you just received 120 volt. What is the meaning? My God, there is a short transmission line now, sending end voltage greater than receiving end voltage greater than sending end voltage. Array, what it will be? Oh, there will be the effect of capacitance. Oh, so that may be either long transmission line or medium transmission line. That conclusion you have to make from the analysis. It's very deep actually. So you just note it down, my dear. Short transmission line is nothing but, this is the representation of a short transmission line. So it's a performance parameter. It is nothing but the sending end current voltage as well as the sending end current, receiving end voltage as well as the receiving end current. Connecting these four parameters, bus, that's all. And also this end. Okay, the Z will be equal to R plus JXL. That will be equal to what, my dear? R plus JXL. So that we can connect to these equations, that means Vs as well as Is by using the ABCD parameter. ABCD parameter. VR as well as I. I hope you remember this ABCD parameter concept. Sending into two parameter V and I will be equal to A, B, C, D, and the receiving end V and I, that's all. Voltage and current, that's all. So from this, we got what, my dear? The value of ABCD. This is the important matrix, my dear. So the ABCD matrix will be equal to Vs and Is will be equal to 1, 1, Z and 0. 1, 1, Z and 0. We are. You have to remember this matrix, my dear. It's very, very important. It's very, very important. It's very, very important. Okay. So from this, my dear, A equal to what? 1, B equal to what? Z, C equal to what? 0, and D equal to what? It is actually obtained by, you can check it. I will tell you how it is. Okay. I will tell you how it is, but for every long transmission and all, for deriving that is very, very difficult. You can derive, my dear, you can derive, but how we can obtain for long transmission line as well as medium transmission line, but things will be more and more complicated. For competitive examination point of view, that is not needed. That is not needed, but for short transmission line, I will definitely tell you how it is obtained. Listen, my dear. So, how I obtain this 1, Z, 0 and 1 now? That is your doubt now, I will tell you. So from this, what is Vs now? Vs will be equal to A into Vr plus B into IR. Am I right, my dear? And Is will be equal to again C into Vr plus D into IR. Is it correct, my dear? So what is the value of A? The value of A will be obtained. The value of A will be obtained, which is nothing but, my dear, Vs by Vr at IR is equal to 0. The value of A will be equal to what? Vs by Vr at IR equal to 0. See, my dear, Vs by Vr at IR equal to 0 means there will not be any current. There is no current means there will not be any drop across this R or JXL. That means the whole sending end will be exactly available. That means if you simply open this, my dear, if you simply open this and here it is one, it is similar to like that. That's all, simple. A voltage here and a voltage here. Okay, this is the curve, this is something. If you simply measure the voltage between these two terminals, there is no current means. If you measure simply a voltage between these two terminals, simply you got this voltage and the difference between these and this you will get in. The difference between these and these two you will get, and definitely it will be 0. Definitely it will be 0. Okay. So as far as the transmission concept, my dear, if IR is equal to 0 means A equal to Vs by Vr. If Vs and Vr equal to 0 means you can simply say A equal to 1. A equal to 1. Is it clear, my dears? Is it clear? Or you can simply think in another way, my dear. Don't forget that. Forget that. It may lead to confusion. Forget that. My dears, IR equal to 0 means what you infer? The potential at this point and potential at this point will be same. Then only there will not be any current flow. The reason for the current flow here is nothing but the potential difference between here and here. If there is no potential between here and here means this voltage and this voltage will be same. Vs will be same equal to Vr. That's all. Simple. Simple. In that way also you can think. That way also you can think. That way also you can think. Okay? Better than that. Na? That is open circuited. Na? That will be, that is not exactly correct. Na? This is exactly correct. Those. Okay, you can use that method. That means there is a voltage, there is also voltage, conductor is there, my dear, but the current will be 0, which is an indication that this potential is same as that of V potential. Then only there will not be any current flow. That's all. Okay. Initially I draw a faulty figure because there is no conductor now. So now it is clear. Now it is clear. Now it is clear, my dears. Okay, so A equal to, what you got? A equal to 1. Similarly, B is nothing but, my dear, Vs by IR. Vs by IR at VR equal to 0. VR equal to 0 equal to the value of B. So V by I is nothing but, my dear, Z now. Vs by IR. See, this is a series network, correct now? So Vs by IR will be same as that of Vs by Is itself. Because in a series connection, IR and Is will be same. So IR and Is will be same means Vs by IR can be also represented by Vs by I symbol, my dear. So which is nothing but, what is voltage by current? It is nothing but, my dear, Z impedance. That is nothing but R plus JXL. So B equal to Z, you got. So clear? Next, C. C can be obtained by, my dear, C is nothing but, my dear, Is by VR at IR equal to 0. That means again you have to make IR is equal to 0, my dear, and Is by VR means if IR equal to 0 means Is also equal to 0. So simply 0 by VR, my dear, simply 0. So you obtained again C. C is equal to 0 you obtain. Coming for D, what will be? The D can be obtained by Is by IR at VR equal to 0, my dear, which is equal to D. Okay, Is by IR equal to what? 1. VR equal to 0 means the receiving end voltage is simply 0 means there will not be any voltage, simply short circuited, that's all. But Is and IR same now. Even though it is there or short circuited, Is and IR will be same. So it is simply Is by R equal to 1. So that D also you got. So now you got A equal to 1, B is equal to Z, C equal to 0 and D equal to 1. That's all. This is just for your understanding, I told. For examination point of view, this is maybe utilized. You can utilize how we can take or how we can derive the parameter ABCD by using this concept. This you can utilize. Okay, is it clear, my dear? Is it clear? And you have to note one thing, my dear. From this you can note one thing. This A and D are same. If A equal to D, then it is called a symmetric network. I have already told you the circuit theory, what is symmetry and what is unsymmetry and what is reciprocity and everything I told you, right? So I don't want to repeat it again. So this is called a symmetric network, and if AD minus BC equal to 1, it is called reciprocal. If A equal to D, it is called a symmetry, and if AD minus BC equal to 1, then it is called a reciprocal. In the short transmission line, you got A, B, C, D as 1, Z, 0, 1. Now it is A and D are equal now. So what is AD minus BC? A, D, 1 into 1 minus B into C, 0 into Z. So 1 into 1 minus 0 into Z equal to 1 now. So AD minus BC equal to 1. AD minus BC equal to 1. So the short transmission line, the conclusion is nothing but, or not is nothing but, my dear, short transmission line is both symmetric and reciprocal. Very, very important conclusion, my dear. For examination point of view, may be directly asked. It's very, very important. It's very, very important. It's very, very important. Is it clear, my dears? Is it clear? Okay. Okay. Just a minute, my dear. I will refill my ink. Okay. It's continuously wetting, not wet, is evaporating, not wetting, it is evaporating. I don't know, maybe the climate may be the reason. And okay, my dear, is it clear? Everyone? Is it clear to everyone? Is it clear to everyone? So that's all about the short transmission line. Next, medium transmission line. My dear, medium transmission line means, you already solved it. These are the parameters now. Up to this parameter you can consider for a medium transmission line. There will be R, there will be L, and there will be C. There will be R, there will be L, and there will be C. So the medium transmission line now, it is represented like this. It is represented like this, my dear. The medium transmission lines can be represented like this. And one more thing is, my dear, the transmission line parameters are distributed, not concentrated, distributed. It is distributed throughout the length, my dear. So for the analysis purpose only, we have to consider it to be a single figure, a small figure. It is just an assumption. It is actually a distributed network. Throughout the kilometers of length, it is distributed. The effective value is taken as the consideration for the analysis easier purpose. Okay, it is not exactly same. It is similar actually, not exactly. Okay, because it is a distributed network. Okay, so the long transmission line, my dear, there will be RL and C. So like that it is moving. There will not be any G. That is a peculiarity, you have to note it. So the medium transmission line can be solved by 3 methods, my dear. Nominal T method, pi method, end condenser method. What are, my dears? Nominal T method, pi method, and end condenser method. Just you need to derive the equation, not derive the equation, just you need the result of the equation for these three. That's all. Okay, let's check one by one. Okay. First one, nominal T method. The transmission line can be represented like, my dear. The transmission line can be represented like. Just a minute. The transmission line can be represented like, my dear, this is R and this is L, C, R, L, which is similar to that's all. The same can be modified by this network, and that is nothing but Z by 2 is having the each parameter value Z by 2, where Z is nothing but, my dear, Z is equal to R plus JXL. Okay, and Y is nothing but, my dear, admittance J omega C. How that J omega C obtained, you know this now? Admittance is nothing but, my dear, 1 by Z. Admittance is nothing but 1 by Z. So 1 by Z for that capacitance will be 1 by minus J divided by omega C now. It's minus omega C divided by J. Multiplying J with both numerator and denominator will be obtained omega C J. That's all. So Y is nothing but J omega C and Z is nothing but R plus J XL. Z is nothing but R plus J XL. Okay, again this parameter, I mean using this T method, my dear, T method is nothing but a medium transmission line can be represented like a T network, that all. Medium transmission line can be represented like a T network. If it is a T network, means this will be each parameter, that's all. This will be each parameter. Okay, this will be each parameter. Is it clear, my dear? Is it clear? So what it's ABCD parameter, na? That you have to know, because VS is there, IS is there, VR is there, IR is there. Definitely it can be connected, but what VS and IS will be equal to. Correct, na? I'll tell you. Quite confusing sometimes. Okay. So you got the value of A and D is equal to 1 plus YZ by 2 and C is equal to Y and D is equal to, sorry, B is equal to Z into 1 plus YZ by 4. Okay, this is A, this is B, this is C, that's all. Got A, B, C, D at all. This is actually obtained by a long derivation, my dear, similar to VS, IS and calculation and all. Similar to now, we did now A, VS is equal to some equation you derive now, VS is equal to A into VR plus B into IR. Again you have to calculate A and B. Like that you calculated, you got A, B, C and D. So the calculation no one will ask you, but this should be asked. What is A, B, C, D? That parameter value you should definitely ask. Okay. Is it clear, my dear? Is it clear? And from here also, you should note one thing, my dear. You should note one thing. What is A? If it is A is equal to D na here also, A is equal to D na here also. So it is a symmetric network. And what is AD minus BC now? A into D, AD minus BC. 1 plus YZ by 2 into 1 plus YZ by 2. That is 1 plus YZ by 2 the whole square now. Minus B into C means Y into Z or 1 plus YZ by 4. Not equal, right? Not equal to 1, right? And AD minus BC not equal to 1. AD minus BC not equal to 1. So not reciprocal. The system is not reciprocal. Let's check. 1 plus yz by 2 the whole square minus bc. Let me check, my dear. Let me check. Okay, let me check and write. Let me check and write. A and D, of course, it is a symmetric network. Let's check AD minus BC. Let's check, is it 1 or not? Is it 1 or not? Check AD minus BC equal to 1 or not. So AD means what? 1 plus yz by 2 the whole square na. 1 plus yz by 2 the whole square minus b into c means y into z into 1 plus yz by 4 equal to what? Let me check, my dear. It is 1 plus 2yz by 2 into, no, simply yz na, plus y square z square by 4 minus y into z, it will cancel each other na. Y and z it will cancel each other, correct? Because y is nothing but 1 by z na, correct na? So it will be cancel each other. It will not cancel. Z and admittance y. So let me check. 1 plus 4. So it will be 1 and y will cancel into this y is nothing but, my dear, j omega c, and z is nothing but r plus j omega c. Okay, r plus j omega l. Okay, you simplify this, you substitute this, definitely you will get 1. Okay, you will get 1, my dear. You will get 1. That means AD minus BC equal to 1 for this nominal T method. Okay, nominal T method also you can take that, it is equal to 1. So this is called a reciprocal network. So nominal T is a reciprocal as well as the symmetric network. That is the conclusion, my dear. That is the conclusion. You can check. Okay, you can check. So it is symmetric as well as reciprocal. Okay, is it clear, my dear? Is it clear? That is the nominal T method. Next one, pi method. Pi method means the network will be in the shape of a pi, my dear. In the shape of a pi, the network will be in the shape of a pi. So that this will be the shape of the network. That means the medium transmission line can be represented like this one. Okay. The medium transmission line can be represented like Z, y by 2, and Vs, Is and Ir, like that you can represent. And the ABCD parameter will be equal to This is the ABCD parameter for what, my dear? Nominal T method. For remember, easily remember for this, I will tell you one thing. Just take these two here. That's it. C is equal to 1 plus y into 1 plus y z by 4, and b is equal to z, and a equal to 1. That's it. This is the easiest way you can remember. Is it clear? Nominal, that means nominal T method, 1 plus y z by a and 1 plus y z by 2 d, that is not changed. There it was z into 1 plus y z by 4 na, z into 1 plus y z by 4 na, in that equation. Check that. Am I correct? Z into 1 plus y z by 4 na, b, and c is equal to y na, c is equal to y na. So z into 1 plus y z by 4, correct na? That y z by 4 just come here, that's all. That is the way you can remember. And z and y, there is no change and all. That z into 1 plus y z 4 come with this z. So that way you can remember, my dear. It's very difficult to remember, I know, but anyhow you can use any trick in order to remember this. But we have to study, right? We have to study anyway. You have to study. Anyway, we have to study. Okay. And this is also, my dear, this is also, you can, if you check, this is also both symmetric and reciprocal. You can check that, or simply by heart this, that's all. Reciprocal or symmetric, bas. If you have doubt, you can check. If you have doubt, you can check. Okay, just ABCD you have to note. ABCD you have to note. Is it clear? Is it clear, my dears? So 1 plus y z by 1 plus y z by z into 1 plus y z by 4 and y. Just interchange that y 1 plus y z by 4 from z to y in the nominal pi method or simple pi method. Okay, so 2 methods over, right? 2 methods over. Analysis of what? Medium transmission line. Next method is nothing but what? End condenser method. Just you need to remember just this figure, my dear, and ABCD, that's all. More than that, it is not sufficient. It is more than sufficient actually. More than that, not important for competitive examination point of view. End condenser method. That means the whole transmission line can be, considered as that's all. The whole transmission line be simplified by this, simply Z and Y. End condenser means in the end it is simply considered like this, end condenser method. So in this method also you have to remember for ABCD. Okay. One plus yz by 2, z by and 1. AB 1 plus yz by 2, z by and z y and 1. A B C D, you can remember like this. 1 plus yz by 2, z 1 plus y, sorry my dear, 1 plus yz only. Okay, 1 plus yz only. 1 plus yz, z, y and 1. So these are the ABCD parameter. So by looking this also, you can say one thing. It is not, of course it is not symmetrical. Of course not, it is symmetrical, my dear. 1 plus yz into 1 1 plus yz is not equal to 1, so it is not symmetrical, of course, but it is a reciprocal. Let's say 1 plus yz a into d, 1 plus yz a into d minus bc 1, let's check that. 1 plus yz a into d minus bc minus yz got cancelled, equal to 1 you got now. So this is not symmetric but reciprocal. That's very important conclusion. Only this conclusion is needed, symmetry or reciprocal, and some a b c d parameter value also, you just need that. You just not need that. More than with that it will not be asked. So that is the end condenser method. 1 plus yz z by 1, 1 plus yz z by 1, z by 1. Okay my dears, is it clear? So you can conclude like, in medium transmission line both pi and t both symmetric as well as reciprocal, but here it is not symmetrical. In condenser method it is not symmetrical but reciprocal. You have a doubt that, sir, why we are doing all this? Why we are doing all this? In order to find the parameters: sending end voltage, receiving end voltage, sending end current, receiving end current, impedance, admittance, etc., etc. For finding all those, we need some models, my dear. We need some models. That's why we are doing this. Okay, that's why we are doing this. Next one, long transmission line, and before that, voltage regulation of a transmission line. The transmission line itself acts as a load, my dears, because it contains R and L and C. So regulation is also for transmission line also. Voltage regulation is also for transmission line. So the voltage regulation, percentage voltage regulation is nothing but I into, simply you can say that sending end voltage minus receiving end voltage divided by receiving end voltage into 100, or in other words, percentage voltage regulation will be equal to I into R cos phi plus or minus X sin phi divided by R into 100, where plus is for lag, minus is for later. Minus is for later. These are the two equations for finding the regulation, where I is nothing but transmission line current, nothing. R is the transmission line resistance, X is the transmission line reactance, right? Reactance. It is nothing but the inductive reactance. XL to XL. Is it clear? Is it clear, my dears? Condition for zero voltage regulation. Next one. That means simply nothing but just VR equal to 0. Substitute VR is equal to 0. Implies I into this is percentage voltage regulation, my dear. This is capital VR, voltage regulation. This is receiving end voltage, my dear. V what? Subscript R. Okay, that is the difference. So is equal to 0 means simply you can say that for lagging power factors, for leading power factor I am saying, for lead I am saying, or R by X, that is the condition for the leading 0 power factor. Leading 0 power factor, which is nothing but why I took lead here. Why I took lead here, you ask me? Because 0 voltage regulation only happens when this is if the expression become minus. If the expression become plus, never it going to be 0. It is always a plus value. There is a chance of 0 only if the expression is minus. That's why I took lead. That's it. Okay. So tan phi equal to R by X is the condition for what? 0 voltage regulation. Next one. Condition for maximum voltage regulation. Maximum voltage regulation can be obtained by, my dear, d by d phi of I into R cos phi it will be plus na, because maximum will be plus na, divided by if you differentiate this with respect to phi and substitute it to 0, you will get tan phi will be equal opposite to that of this, x by r. That's the only difference. That is the only difference. Just the important thing here is this is one and this one. At voltage 0 voltage regulation condition, tan phi is equal to R by X, and maximum voltage condition relation, tan phi is equal to X by R. Here, my dear, this is XL, correct na? This is XL. I have already told you na. This is XL. So this is XL. XL by R. Okay, that is the voltage regulation. The sending end voltage minus the receiving end voltage. Is it clear? Is it clear, my dears? Long transmission line. So the long transmission line can be represented like everything will be there, my dear. Everything will be there. Everything will be there. Everything will be there. Long transmission line can be represented like everything will be there. Both R, L, G and C, all 4 parameters will be there. And the analysis is actually very difficult. But there are certain terms you have to note it down from the long transmission line. That only we need for examination point of view, but not for the analysis. The analysis is very difficult actually, but not for us. The syllabus we don't need that. Okay. Some terms regarding the long transmission line is only the difference. Only the important. First one, characteristics impedance. My dear, characteristic impedance ZC is nothing but root of Z by Y. Root of Z by Y. And Z is nothing but here, this is Z, my dear. And this is Y. Z is nothing but, my dear, R plus JXL. Simply JL omega, na? JL omega. And Y is nothing but G plus JB. Is nothing but one by R plus J omega C. Am I right? 1 by R plus J omega. G is equal to 1 by R. J beta is nothing but, my dear, beta is the susceptance. It is equal to 1 by reactance, and the reactance is nothing but capacitive reactance. So 1 by minus J by omega C. Correct now? So omega C goes upper, so it will be that. So what is Z by Y now? Characteristic impedance is nothing but, my dear, root of Z by Y. Okay, just remember this equation, my dear. Z is nothing but R plus J L omega whole divided by simply G plus J omega C. You can use like a G plus J omega C. Okay, this is called the characteristic impedance, my dear. And for lossless transmission line, R equal to 0 and G is equal to 0. What is the meaning of lossless transmission line, my dear? Lossless means there is no loss. So in series impedance consideration, there is no loss means there will not be any R. So R will be equal to 0. For parallel consideration, there is no loss means this will be infinity. This resistance will be only infinity if G will be equal to 0. That's why G is equal to 0. So substitute in that, the ZC will be now, for lossless transmission line, the ZC will be now termed as ZS or Zn. Is called the, I will tell you, is called root of J omega L divided by J omega C. Omega will cancel, root of L by C. Is called the natural impedance. Natural impedance is called the natural impedance, or you may be familiar with other name called surge impedance. So the characteristics equation, the characteristic impedance is nothing but root of Z by Y. Simply substitute the value of Z and Y there, you will get some value. And for lossless transmission line, R will be equal to 0 and G will be equal to 0. By assuming that consideration, so ZC will be equal to ZS or Zn, both called surge impedance or natural loss. This equation is triple star, my dear, very very important. Very very important. Many question paper I have seen this. They given a 400 kilometer transmission line having L equal to this much and C is equal to this much. Calculate the value of the surge impedance. You will think, oh my god, the length will be there now. So sometime you may multiply root of L by C, you may take and multiply it with 400. Wrong. Because the characteristic impedance or natural impedance or surge impedance, not characteristic impedance, natural impedance or surge impedance is only depend upon L and C, my dear, not depend upon the length. That means you consider this for 1 meter line or you consider it for 1000 kilometer line, the characteristic impedance, I mean the surge impedance or the natural impedance of the line will be same, L by C, root of L by C. Very 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 important relation. Very 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 important relation. ZS is equal to root of L by C. ZS is equal to root of L by C. Is it clear, my dear? And one more note you have to note. For overhead transmission line, if ZS is equal to 400 ohm, then for UG underground transmission line, ZS will be equal to 40, which means ZS will be 10% of ZS in overhead. only 10% ZS will be there for underground. And like this, ZS UG will be equal to 10% of ZS in overhead range. That means there is a chance of also asking, there is a chance of asking a problem from here also. Someone give you a long transmission line having the surge impedance of 400 ohm. Then what will be the same for underground cable? Simply cut 1 0, that's all. The answer will be there. Okay. So that's all, my dear. And one more thing you have to note. Yes. Lot of chances of asking one word question from this area. One word question only, not the derivation or not big things will not be asked. But what is characteristic equation, characteristic impedance, and what is surge impedance, what is natural impedance, like that you will be asked. Next, surge impedance loading. Surge impedance loading. Surge impedance loading. Is everything clear to you, my dears? Why I am very fast now? I think you are got a standard now, so you can easily follow me. In that concept I am taking this. Okay. If I move very sluggish manner, then the syllabus will not be completed, my dear. You can adjust the speed of the YouTube to 0.5x and you can listen very slowly. It's your time now. You can enjoy. Okay. It is not live class, right? So you can adjust the speed, no issue. Surge impedance loading. Listen, my dears. The transmission line is consist of what? A resistor as well as inductor as well as capacitor. So there may be chance of generation of reactive power. There may be chance of absorption of reactive power by the inductor. There may be a chance of generation of reactive power by a capacitor in the transmission line. There may be a chance of absorption of reactive power by the inductor. The two possibilities are there now. Suppose let the generated reactive power equal to absorbed reactive power. If these two are same, my dear, these two are same at certain condition, that is QL will be equal to QC, which implies QL I square into XL will be equal to V square by XC. V square by XC. QL equal to QC or I square into XL is equal to V square by XC, where V square by XC is nothing but power P is equal to V square by R now. So power P is equal to V square by R, V square by XC. Power P is equal to also I square into XL or I square into R, right? So I square into R, I square into XL, that's all. So now V by I symbol is I square by V square equal to or simply I square XL into XC equal to V square or I square by V square equal to 1 by XL into XC. Am I right, my dear? Yes. Or V square by I square will be equal to XL into XC, or simply V by I will be equal to Z is equal to root of XL into XC. It's nothing but, my dear, root of XL, L omega, XC 1 by C omega. Omega will cancel. Root of L by C is equal to Z. E is equal to Z. Z is equal to what, my dear? Root of L by C under this condition. So I square into Z or V square by Z is called the surge impedance loading. I square into Z or V square into Z is called the surge impedance loading. You can represent Zn. Zn, because Zn you already derived now, so you can use that word Zn, natural impedance line, characteristic equation, characteristic impedance ZC, and from that you got surge impedance or natural impedance now, so that you can use Zn. So whenever the Zn will be equal to root of L by C, at that time what will be the power of the, I square into Zn, or at that time what will be V square by Zn. Both I square into Zn or V square by Zn at that time is called the surge impedance loading. Loading is nothing but, my dear, power. Loading is nothing but the power, or what the transmission line actually loaded at that time, and how, in what manner the transmission line is loaded. Surge impedance loaded the transmission line. Surge impedance loaded the transmission line. Okay, you can think in that way. You can think in that way. That is called the surge impedance loading. So at this time, so at the surge impedance loading, and you can also add one more thing here. At surge impedance loading, what will be the power factor? Power factor equal to 1. Power factor equal to 1. And one more thing you can add. If loading less than surge impedance loading, SIL means surge impedance loading, SIL, then QC greater than QL will be happen, or leading power factor. If loading greater than surge impedance loading, that means there will be a natural loading of the transmission line, my dear. That is called a surge impedance loading. At that time, Z will be just a root of L by C. So at that time, what is the power? Okay, that is called the surge impedance loading. If the transmission line loaded now it is loaded less than surge impedance loading, means less than root of L by C, Z value means, what is the meaning, my dear? What is the meaning? What is the meaning of that is that it will be more what? Capacity loading. That means QC greater than QL, and if surge impedance loading greater than surge impedance loading, then QL will be greater than QC, or lagging power factor. These also you just note. Okay, just note this, my dear. This everything I written on my board is very, very, very important. Note every point. You don't skip every point or any point, my dear. It's very, very important. That much. Every line is important. Every line is. I am taking the crisp of the content. Just a crisp of the content I am taking. Okay. If I explained it for very long time, means nearly it will take 1 or 2 months to complete a simple subject, power system. At least 2 months you need, 2 or 3 months you need. Okay. Okay. Okay, my dear, that's all about today classes. So let's meet again tomorrow. Thank you. Bye.